Hello, welcome to Flip. So today we are on acids and bases again. We'll be talking about pH measurement. Okay, so pH really just tells us how much H plus is present in the solution. Okay, and it has a range from 0 to 14. 0 being acidic, 14 being alkaline, and 7 is neutral. Okay, so it's like this. 7 sits in the middle of 0 and 14. This is acidic. This is alkaline. Okay, so moving here, it becomes more acidic. Alkaline goes the other way. Okay, as you increase the number, it becomes more alkaline. As you decrease the number, it becomes more acidic. There are a few ways to measure pH. Okay, the first one is the most straightforward. Okay, is using a pH meter. Okay, it's also the most accurate. Because what you have to do is really just to, for example, this is your solution. Okay. You just have to put this end inside the solution. Okay. Just poke it inside and the display will show you what's the pH of the solution in the beaker. Okay. So it's really just an electrode. Okay. Connected to a display unit, this one. And it displays the pH when the electrode is being dipped into the solution. That's all. It's very straightforward. But you won't have some people may not have the luxury of having a pH meter, so they may opt for a cheaper option. Okay, there are two more ways to measure pH. First one being an indicator. So an indicator really just is not as good as the pH meter as above, because it only exhibits different colors at different pH ranges. Okay, take note, it's a range. Okay, it's not an exact pH value. So it only tells you if it's above or below certain pH. What do I mean? For example, if I have this solution, okay, I do not know what pH this is, correct? So maybe what I can do is I add a drop of methyl orange inside. Okay, when upon contact with the solution, the methyl orange will change color. It will either turn red or turn yellow. If the solution inside here is say 3 pH at 3, it will turn red color. Okay, makes sense, right? If it's at around say 7, okay, it'll be around here, right? It will be yellow. Okay, but if it's at pH 9, it's also yellow. So it really is not a good indication of what pH it is. It just tells you what range is it in. Okay, so it's very important. The word here, range. Okay. For bromothymol blue, okay, it's the same thing. It's just that it's different color at different ranges. From 0 to 7 pH, it's yellow. Beyond that, it's blue. Okay. Phenolphthalein, okay, this is a hard word to spell and to pronounce. But phenolphthalein is colorless at 0 to 9 pH, and upon the turning point at pH 9, it will turn into pink color from 9 to 14. Okay, so indicator is not a good way to find out the pH of a solution. Okay, because it only gives you a range. But in the case of if you do not have access to other pH measurement techniques, this is one of the ways to use it. Okay, so remember, it's a range. Okay, next one is a universal indicator. Okay, it's so the word indicator here, okay, tells you that you are using color to determine pH. So it has all the colors of a rainbow, okay, red to purple. As the pH changes from 0, this is 0, right, to 14, okay, the color changes from red to purple. Okay, you can see. So how it works is like this. This is my solution of interest. Okay, I don't know what pH it is. Okay, I have to just drop a few drops of solution of universal indicator solution into it. Okay, upon contact, okay, when you mix it, it will show a color. For example, when I put this universal indicator inside, it turns pink. It turns green. Correct. This green, I will compare it with this is called a pH scale, correct? I'll compare this green with the colors present. So I can see that, oh, this is most likely a pH 7, okay? Because based on the intensity of the green. If, for example, in another case, This is my solution, okay, colorless solution. I don't know what pH it is. I drop a few drops of pH, of universal indicator in it. And it turns, for example, say, this color. Okay, so this is like a light blue, right? Okay, then maybe I will say that, oh, its pH is probably around 9 to 10. Okay, so as with the indicator above, universal indicator cannot give you a definite pH as well, because there are few errors, right, human errors to be made, because you cannot correctly determine what shade of blue this is. Alright, I know it's between 9 and 10, but I don't know what it is. Okay, maybe a good one would be 9.5, but as with the indicator, it's not accurate. Okay, so the best way is to use a pH meter. Okay, so finally we talk a lot about pH, right, all this, but what's the real impact on this on environment? Okay, so one environmental concern is agriculture. Okay, you know, different plants like different pH, right? Okay, some prefer acidic, some prefer alkaline. Okay, different plants have different ways of growing, right? And so they prefer different kinds of environment. So for those plants that are more suited for alkaline conditions, okay, when you add fertilizers or when there's acid rain, okay, you will make the soil too acidic. Okay, this is not good for the plant, right? Because the plant likes to be grown in alkaline environment. So what can you do? You can add slaked lime, okay, which is calcium hydroxide, to neutralize the excess acid, okay, by increasing the pH. Okay, for example, if the pH is around say 4, right, this is acidic, am I right? So when you add calcium hydroxide, this is a base, correct? So a base, okay, or alkali, will react with the acid, okay, via neutralization to give me pH around 9, which now the plant likes because now it's alkaline. Okay, and so the pH is being increased by neutralizing the excess acid. Okay, and now the plant can grow happily. Okay, and that's the end of this whole chapter on salts and bases and acid.